Assalamualaikum and greetings. My name is Muhammad Razak Akmal bin Azman. My ID number is MA22138. So I'm from Group 2. I will discuss about my calculation and explain it for the question A1 reactor R1301. So no wasting time right here. I will show it right now. So first step is using formula C not P. So as you can see the formula, and then we need to find the K1, K2, and K3. So find it in table A1, page 9 in handbook, type reactors, description, jacketed, non-agitated. So and then we need to find the area volume using the formula of volume pi r square and h multiply together, and then we get the answer. So the height total, and then we get the 3.55 meter. And then we calculate for the C naught P, and then we get the answer 1975.4194. And then step 2, we need to find the B1, B2, FM, and FP. So B1 and B2, we can find it in table A4, page 29 in handbook, section, process versus vertical, and FM equals to 1, process vessel CS I equals to 18, page 27 in table A3. So using the formula of FP vessel, so P for the reactor between 6 and 7 stream number, so plus and then we divide it by 2. We get the bar pressure for 14.95 and minus 1 get the P 13 equals to 13.95 bar. And then we calculate all together using the formula of FP vessel. We get the answer for FP 1.5581. And lastly, we get the bare module cost CBM and CBM 2019. So for the CBM, we need to calculate all of them. C naught P multiply with in bracket B1 plus B2 FM multiply with FM multiply with FP. We calculate it together, we get the answer 10046.4734. And lastly, we're using the step C to find the bare module cost for the 2019 multiply with 607.5 CBM multiply with CBM, and then we get the final answer 6103232.591. That's all for the question A1 reactor R1301. Thank you.
Assalamualaikum. My name is Hafnia Adiba binti Muhammad Harun, KA2204. I'm going to explain how to estimate the bare module cost CBM for second stage WGS reactor R1302. So this is the PFD given. Firstly, we need to find the H, which is the height of the reactor, 0.375 plus 0.375 plus 1.9. It will be equal to 2.65 meter. So then we need to find the A, which is the volume of the reactor. We will use the equation pi r square H. So pi, and then we need to times the radius, but it is given the diameter, so we need to over 2. 0.75 over 2 square times the H that we have calculated earlier. Then we will get 1.1707 meter cube. Okay. Then we need from table A.1 we can find K1, K2 and K3. So how to know where to find this? We can look at the table. Okay, so the equipment type that we need to find is reactor, and it is stated that the equipment description is jacketed, non-agitated. So we can look at this and find K1, K2 and K3, which is 3.3496 and K2 negative 0.2765. K3 is 0.0025. Okay, next we need to, after we find the K, we can find C naught E by using the equation log C naught P equal to K1 plus K2 log 10A plus K3 times log 10A squared. So by using this equation, we can substitute all of the information that we have calculated earlier into this equation. So then we will get C naught P will be equal to 2141.3443. Then we need to find the B1 and B2. How to find the B1, B2? We can look at the table. So we can look at this table. So the equipment type is process vessels, and the reactor that we need to calculate is vertical. So then we can look at this B1 and B2, which is 2.25 and 1.82. And then we need to find FM. FM is and the information given is about process vessel. We can look at this table. So for identification number for process vessel, which is vertical, is 18, and the types of material is carbon steel. So by looking at this identification number, we can find the FM, which is when identification number is 18, we can see that FM material factor is 1, will be equal to 1. Next, we can find FP. How to find FP? We can use this formula, which is P plus 1 times D over 2 times 850 minus 0.6 times P plus 1 times plus 0.00315 over 0.0063. So there is one unknown in this formula, which is P. So we need to find P. How to find P? We need to look at the reactor at the PFD given. So this is the reactor, and then if we look here, the P in from this reactor is 14.2. Meanwhile, the P out for this reactor is at 8. So at scene number 8, we can know that pressure is 13.8. Therefore, the pressure out of this reactor is 13.8. So we can find the P for this reactor by using this formula, which is 14.2 plus 13.8 over 2, which will be equal to 14 bar. Then we need to change bar to bar gauge, which is by minus the P that we have calculated earlier. So 14 bar minus 1 will be equal to 13 bar gauge. Therefore, answer will be P equal to 13 bar gauge. And then we can substitute the P that we have found earlier into this formula, which is to find FP. And then we will get 1.4902. And then after we have calculated all of this information, we can use it to find CBM, which is using this formula, which is C naught P times P1 plus P2 plus which is C naught P times P1 plus P2 times Fm times Fp. And then after calculated all of the information here, we can know that the CBM is equal to 10625 times 7016. However, we need to change it into SEPC of 2019. Then it is given that SEPC 2019 is 607.5. Then we need to times the CBM that we have calculated earlier, and then we will get 6455113.72. That's all for me. Thank you.
Assalamualaikum, my name is Farisha Ada binti Faizal Rizal, AA22007. So I'm going to explain about question 2 to find the CBM of sine gas heater H1301. First of all, based on the equation to find CBM of a heater, we have to use CBM equal to C naught P FBM times FP times FT. So the first step is to find the CP naught. The equation given is log 10 CP naught equal to K1 plus K2 log A plus K3 log A square. To find the case of a heater, we have to look at the table A1. It is a steam boiler heater with K1 6.9617, K2 negative 1.4800, and K3 0.3161 with capacity in kilowatt unit. To find A, we have to convert megajoule per hour to kilowatt. Based on the unit conversion given in the question, 1 megajoule per hour is equal to 0.28 kilowatt. So, 696 megajoule per hour is equal to 194.88 kilowatt. Put it into the equation and calculate it with your calculator. You should get Cp naught is equal to 169,889.8901. Second step, you have to find the FBM. Since it is a steam boiler heater, we use hot water to generate it. With ID number 56, we can get FBM is equal to 2.2. The third step is to find FP. FP equation is log 10 FP equal to C1 plus C2 log 10P plus C3 log 10P squared. But before we use the equation, we have to find the pressure first. Pressure in of the heater is 16.7 bar and pressure out of the heater is 15.2 bar. Calculate the average of both pressure and we get 15.95 bar. 15.95, just minus it with 1 to get it into bar unit, which we get 14.95 bar. Since the pressure is less 20, we have to use C1, C2, C3 is equal to 0. Put it into equation and we should get FP is equal to 1. The fourth step is we have to find the FT. FT is equal to 1 plus 0.00184 delta T minus 0.0000335 delta T square. To find delta T, final temperature minus with initial temperature. The final temperature given is 320 and the initial temperature given is 115. Minus it, you should get 205 degrees Celsius. And again, put it into the equation, you should get 1.2364. Last but not least, you have to find the CBM. CBM is equal to Cp naught 169,889.8901, FBM 2.2, FP 1, and FT 1.2364. You should get $462,114.0923. And the final step, to get CBM at 2019, you have to times it with 2019 sub C. Sub C of 2019 is 607.5. Just multiply the CBM that we calculated earlier and times it with 607.5 to get the answer. The final answer is $280,734,311.100. Thank you.
Hi, my name is Nuratika binti Ahmad Arzali and my ID number is 22134. Now I'm going to explain the calculation for the shift syngas separator V1301. So first step is to find the CPO by using the equation stated from the page 5 of the student handbook. So to find the value of, we can find the value of K1, K2, and K3 by using from the table 8.1 from page 8. To find the value of A, we use the formula of area for the cylinder, which is pi d square h over 4. And the value of A and D, we can get it from the table 2 in the question. So the answer is 0.5348 meters square. Next, just key in the value in the equation, and then we got the answer, which is 2417.8455. Second step is to find the B1 and B2. So the value of B1 and B2 are 2.25 and 1.82. And you can refer to table 8.4, which is page 29 from the student handbook. So third step is to find FM. Based on the identification that applied, which is 48. So the value of 48 concludes that the value of FM is 1. Next, we need to find the FP. So we need to calculate the value of P using the pressure that is entering, which is 30.8, and pressure that going out, which is 12.7 and 11.7. So we need to find so we can calculate the average outlet by adding the pressure going out divided by 2. And then the answer, we can passed with the pressure entering divided by 2 to get the value of P. So we need to find the value of FP from the equation A.2.1, which is page 22 from the handbook, and the answer is 1.2473. Finally, using the equation from A.3.1 at page 26, key in the values of CPO, B1, B2, FM, and FP in the equation that we acquired before this. So the answer is $2,422 and 36.56. Finally, find the CBM for 2019 by multiplying the value that we got from for CBM and the plus cost index in 2019, which is 2422.3656 multiplied by 607.5 that were provided in the question. So the final answer is 1,471,587.1020. So that's all from me. Thank you.
So going on with the question D1, it's stage cooler E1301. So as usual, we need to find the C naught P. Before that, we need to find the K1, K2, and K3 from the table A.1. So we get all of it. And for the area, we can get it in table 2, already given 67.2. And using the formula of C naught P, log C naught P equals to K1 plus K2 log A area plus K3 in bracket log area square. And then we get the final answer 21873.5630. And for the step 2, we need to find the B1, B2, FM, FP, and P. For the P, heat exchanges is between 7 and 8 stream number. 14.7 plus with 13.8 divided by 2, get the 14.25 bar, and minus with 1 to get the P equals to 13.25 bar. And then we get the B1 and B2 from the table A.4 page in page 29 in handbook. Equipment heat exchangers description floating head. So 1.63 and 1.66, and FM equals to I equals to 2 equals to 1.4 in table A.3 in page 27 in handbook. So lastly, FP. Before that, we need to get the C1, C2, and C3 from the table A.2 in page 24 in handbook. So using the formula of FP, we get the final answer 1.0096. And lastly, for the step 3, we need to find the bare module cost and bare module cost for the 2019. So bare module cost, C naught P multiply with bracket B1 plus B2 multiply with FM and multiply with FP in bracket. And we solve it, we get the final answer 86976.0760 $. And lastly, we get the final answer for the payment cost for the 2019. We multiply the CBM multiply with SEPC 607.5. We get the final answer 5283.7966. 5283.7966.1700 $. That's all from me for the question D1 interstage cooler E1301. Thank you.
Hello, my name is Akmal Akil bin Karudin, Ideometry KA21021. So I will explain about the question D. Number 2 is a low pressure steam generator E1302. So the formula we use is CBM CP equal to CP naught B1 plus B2 FM FP. So we must find the CP naught. So to find the CP naught, we must calculate K1, K2, and K3. So K1, K2, and K3 we can get the value in table A1. In table A1, and the area value A is given 31.7 meter square. So we get the answer. For B1 and B2, we choose the heat exchanger floating head and can get the table A4. Table A4. So next we calculate the identifying number, because it's 2, so FM is 1.4. After FM, we calculate the FP using a formula, C1, C2, and C3. We can get C1, C2, and C3 value for the table A2. And for the P value, pressure value, the steam is steam 8, and the outstream is stream 9 and 10. So the output average for steam is uh, 12.2 bar, and the pressure average, input and output, get 13 bar. And because the pressure is using bar, so we minus 1 and get the 12 bar. So the pressure we get, so substitute in the formula and we get the FP value. So after we calculate the value, we can substitute into the CBM formula and we get the answer for CBM. And lastly, we times with the CHEPCHI for 2019 for 607.5. So we get the answer. Next, I will explain about the question D number 3 is a reactor influent cooler, or E1303. So same as previous question, we use the formula CBM CP0 B1 plus B2 FM FP. So find the CP0 first. K1, K2, and K3 we can get for the table A1. For the A value is a given 62.2 meter square. So substitute to the formula and we get the answer. The second is B1 and B2 value. Heat exchanger and floating head is given at the table A4. So we get the B1 and B2. So we can continue to find the identifying number. Identifying number is at 2, and we can get FM by looking at the graph, and FM is 1.4. So after FM, we calculate FP. For use the formula FP. C1, C1, C2, and C3 can get the for the table A2. And log and the pressure, same as previous question. In stream is 30.8, outstream is 12.7, 11.7, and the output average for stream out is 12.2 bar, and the pressure average all is 13 bars. So we minus 1 to get the bar, 12 bar. So we substitute into the formula, so get the FP value. And after they get all the value, we can substitute into the CBM formula. So we calculate and we get the answer. Same as previous question also, we times to G 2019 for 607.5 and we get the answer. Thank you, that's all for me.